Okay, so our second to last section for this week is 7.3. And it's going to focus on solving equations and a little bit with inequalities graphically. Okay, there's going to be a lot of review here about how we write our answers. Remember, when I ask you to find all solutions, okay, if I ask for all solutions, your job first is to find all the answers in one cycle. Start with that. And then what do you put on the end of all those answers?
The period.
N, yes. Then put plus the period times n. So you have to take into account the fact that the answer is going to repeat every cycle. Right? So this is where you put plus period times n. That's what that second thing means. Take into account the fact that the answer repeats every cycle. Now, since we're going to be getting into some more complicated trig functions, we may have more than one or two answers per cycle. I mean, if you had like a sine and a cosine wave intersecting, they can cross each other more than twice in a cycle. Depends on how you set it up. Now, the more they cross, it doesn't really get harder, it gets more tedious. You have to find intersection points for every single time they cross. Okay? So that it could take a while if you had like 5 or 6 or 7 of them to find. Right, so let's do this one. This is one that you guys we could do algebraically using the ASTC chart, but the focus today is more graphical. So I'm gonna stick with that. Even though I think the graphing one for this is much slower. Pat, can you remind me, how do I do this graphically?
You would put point A in for one, and then sine of x in for the other one.
Okay. Sine of x. Right. What would I want to do next?
Set your window to
yes.
1 period. Exactly.
Set your window to one cycle. You don't want to get confused by thinking there's more answers than there really are because you're looking at multiple cycles. What's the formula to find the period of sine? Yep.
Is that 2 pi over b?
Yes. For sine, cosine, secant, and cosecant, it's 2 pi over b. For tangent and cotangent, it's 1 pi over b. Okay. So b in this case is 1, so my period is 2 pi. That's important because now I know what to put on the end of each answer. Plus period times n, plus period times n. Now I've got to find the start points. I've got to find 2 specific answers in the same cycle. Okay? And that's where I'm starting from. Technically, it does not matter which cycle you grab the answers from. I'm going to grab them from the first positive cycle. I mean, you could do negative 2 pi to 0. That would work. You'd just have the first 2 negative answers. Okay? Just like standing on a different square to start. But you're still going to paint everything left and right. Okay. What about the highest and lowest that sine goes?
1.
Yes, I don't really need negative 10 to 10. In fact, that's going to make it hard to see the answer. But this should look hopefully pretty good. Okay. Now, what did I do wrong?
You have it in degrees.
I'm in degrees. So one of 2 things. Either switch over to radians, which is what I'm going to do. Or instead of doing 0 to 2 pi, you did 0 to 360. Okay? But you can do it in degrees or radians. Depends what the problem asks for. Now I should be okay now. Okay, so usually with a sine or cosine function, a horizontal line hits it twice, unless it's at the peak or the minimum. Then it might only hit it once. All right. So now second calc intersect. If you just hit enter 3 times, you'll get one of the answers. You're going to get whichever one you're closer to. So that's 2.21. And the other answer is just the inverse sine of 0.8. Okay. So again, if I was doing it, I would have just pressed inverse sine 0.8 and I would have been done with the problem already. Okay. The graphing, it takes a lot longer. So second calc, intersect, move the cursor closer. And when you do inverse sine of 0.8, you should get 0.93. Okay. And that's all solutions to the problem. That's all solutions. Any questions on that? Okay, so kind of a review, a little bit. Basic trig function, no exponents, nothing too fancy. All right. So another way we could have solved this, which nobody mentioned, is you could have put everything on one side. You could have put all of this in y1. And what you would have been looking for now is the roots. Right? You would have been looking for where it equals zero, the zeros. All right, so setting an equation equal to 0 and solving it that way, that gives you the roots. Something we talked like way back about in chapter 1 or 2, finding roots. So if you have an equation, it's just a little vocabulary here. But if you have an equation like y equals f of x, that's called, and it's periodic. Periodic means that it looks the same every cycle. Okay? Something like a parabola, no, it's not periodic. Periodic usually has a sign, it has a trig function in it. Okay? So when you set it equal to 0 and solve it, you're setting up what's called a periodic equation. It means it's an equation that when you solve for the roots, you're going to get multiple answers. And to represent that, we put plus period times n. So a periodic equation is just an equation that has lots of answers. Or I guess it could have no answer. If you had that, and you graph them, you try to find where they cross. If it doesn't cross in the first cycle, then it's never going to cross in any cycle, because every cycle is the same as the one before. All right. Okay, this part, you guys have seen this before too. So let's suppose you get an equation, you set it equal to 0, and you have n solutions. In the problem we just did, we had 2. There they are. 1, 2. So the idea is you find all the solutions within one cycle. If you set your window to one cycle, it makes your job easier. Then you're not looking at other stuff you don't need to. Okay, so set your window to one cycle, and then to write all your solutions, you take every solution that you found in one cycle and then put plus the period times n. Plus period times n on all of them. So I'm just reviewing that again. I think somebody had asked me though earlier, it was Adri, what is n? So n is an integer. N is any integer you want. So you can only add multiples of the period. You can't go 1.5 cycles later. No, you either go a whole cycle later or a whole cycle earlier, but you can't go in between. Right? So that's what our answers are going to look like today, if they ask for all solutions. Graphing calculator will give us those using intersect. We have to find the period by hand. That's up to us. Questions on that? Okay, I don't think we're going to do any problems that have, you're not going to have like 20 solutions in a problem, but we're going to do some that have more than 2. We'll do some with more than 2. So, eventually we're going to start to look at something like this. It's equal to 0, so we're finding the roots. And I think everybody in here could probably tell me what the period of sine is, because we just did that in the first example. And what the period of cosine is. But this is cosine squared, right? So we've got multiple trig functions in the same equation. So how do we find the period of that whole thing? Well, it starts with finding the period of each individual term. Okay? So like in this problem, find the period of cosine squared, which I'm going to show you how to do, and then find the period of sine. Okay? Find them separate. And then the period of the whole thing is the least common multiple of the individual periods. So let's say you had a term with a period of 3 pi, and you had another one with a period of 4 pi. What's the least common multiple of 3 pi and 4 pi? How much? 12 pi, yeah. So if you had a term that had a period of 3 pi, another one that had a period of 4 pi, the least common multiple is 12 pi. That's how often the whole thing would repeat. It's the LCM of the individual periods. Now, the way we're going to figure out the period of cosine squared is pretty much just kind of like investigating it. We'll graph it, we'll look at it, and see if we can figure out the cycle. Eventually, though, I'm going to give you guys a table that summarizes the periods. For even, it pretty much all that matters is the exponent even or odd. That controls what the period is going to be, along with the number in front of x. And we call that b in our formula. All right, so let's just graph cosine squared. I don't want to graph all the other stuff because that's going to complicate it at first. Let's just graph cosine squared and see if we can find period. All right, first thing we got to get used to is the way you write it on paper and the way you write it in the calculator usually don't look the same. This means this. If you want to put it in your calculator, you have to do it the way I did on the right. Okay? And you have to put parentheses around the cosine t, because if you don't, you're going to do this, which means take t, square it, and then plug it into cosine. That's different than plugging t into cosine, getting that answer, and then squaring it. Okay? But cosine squared t means what I put on the right. Okay, so let's graph it. All right, so we have cosine x, close parenthesis, square it. Now, I'm going to set a window. I'm just going to leave it like that, 0 to 2 pi. Let's take a look at it and see if we can figure out how long the period is. If we look at it, let's just pull this over here. All right, this is 0. This is 2 pi. How many cycles do you think you're seeing on the screen? 2. Starting at the highest, down. Okay, you're back to the highest. That's 1. Starting at the highest, down, back to the highest. That's 2. So if you're seeing 2 cycles from 0 to 2 pi, that means 1 cycle is how long? Pi. So now we know the period of cosine squared. I'm just going to get rid of that. It's pi. What's the period of sine? 2 pi. Now, what's the least common multiple of 1 pi and 2 pi? 2 pi. That is what you're going to put on the end of every answer you find, plus 2 pi n. Okay? Now, we type the whole thing in and see where it crosses the x-axis. All right, so we've got 2 cosine squared. Make sure that you don't accidentally put a 2 in parentheses with cosine, because if you do that, then you're going to square the 2 and get 4. You don't want to square the 2, just the cosine x part. So that's fine, just like that.
Why don't you have the cosine parentheses?
You can do it either way. It won't matter. If you did this is what you were thinking?
Yeah.
If you hit graph, just to see what it looks like, there's there's the way I did it, and here's the way that you said with the parentheses. Comes out the same. But either way, so I guess you know what? I can even write a third way right here then. All right. Okay. So now let's just do it this way. Put in 2 cosine squared x plus sine x plus 1. Okay. Window should be set to 1 cycle. So you're going to get every answer that's in 1 cycle. Let's hit graph. And we're looking for how many times it crosses the x-axis. All right, so we're not seeing part of what's happening. It's not important because we're not looking for how high it goes. But if you did want to see what was happening, I think if you set that around like 5, you would see the whole graph. So most of it was up above where we couldn't see it. And that's going to end on the edge of the screen right at the same height that it started at. So that's what 1 cycle of that graph looks like. It's still a wave, but it's a little bit different shape now, okay, than what we're used to. Okay, so how many times does it cross the axis? Once?
Maybe 2.
Maybe 2, I'm not sure. I can't tell. So what should I do?
Zoom.
Zoom
In.
in. All right, so let's just get kind of close to it. It's probably good enough. So the question is, does it go below it and come back up?
Yeah.
Boy, still kind of hard to tell. I'm thinking it doesn't. I'm just going to zoom in one more time. If you zoom in 2 times, that's usually enough. It's not going to like you're going to have to zoom in 6 times. I'm not going to give you one like that. So let's just zoom in one more time and make sure that it doesn't go just barely below it. Right, so let's see.
Oh my god.
Wow. Look at that.
Yeah, that's that one.
So, you know what? Let's go like this. Let's go second calc 0. And let's try to calculate a 0 between here. And I'll go just a little over halfway, which I think it's below it, just barely. It's hard to tell. So let's try from there to there and see. And do my guess. Okay, it's not finding a 0. Oh, it did. So it put it right in the center. So yeah, it doesn't end up going below it. Okay, the 0 is right in the center. Then that kind of tells me. If the 0 was off to the side, then I would say, okay, then there's probably another 0 off to the right side. But the only 0 is 4.71. Okay. So there's 1 answer per cycle. And it's at 4.71 and repeats how often? Every 2 pi. So that's what you're looking for. Okay. Question on that one? Okay. All right, let's look at this one. Now, we could do it as an intersect. It's fine. But we're just practicing a little different. We're practicing doing it as a root. Same idea. How could I get this equal to 0? You could subtract tan x from each side, or 3 cosine x. It doesn't matter. But if you want to do it as a root problem and not an intersect, just put everything on the same side. So I'll do tan x minus 3 cosine x. So step 1, find the period of this whole thing. What's the period of tangent? Pi over b, but in this case b is just a 1. What's the period of cosine? 2 pi over b, but b is a 1. And what's the LCM? 2 pi. 2 pi comes up a lot. Now, that's not the answer. That's just what you're going to put on the end of your answer, plus 2 pi n. Okay. Now, let's graph that and see what we got. So, tan x minus 3 cosine x. Okay, so there's no powers, there's no exponents, so there was nothing tricky there we had to figure out. What should my window be to show one cycle? Yep, 0 to 2 pi. Always start with one cycle so you can see the big picture, and then if you need to zoom in on an area, do that after. Now, how high and low does tangent go? Infinite. So you're not going to be able to see the top and the bottom. But what we could do is go like -5 to 5. That'll probably be good enough. Right, so far we have at least 2 solutions. And it should end on the right exactly where it started on the left. So these 2 pieces right here and here would actually be connected if you adjust your window correctly. All right, so this one I think is pretty clear. How many solutions? 2. So we're going to go second calc intersect. Second calc 0, because we're finding where it crosses the axis. I'm going to do the one that's further to the right. If somebody else does the one further to the left, that will be helpful. All right, let's pick a point left, pick a point to the right, and do your guess. So the second answer is 2.13. And that answer will repeat every multiple of 2 pi. How about the first answer? 1.01. Okay. And that answer repeats every 2 pi. Okay. Questions on that? Okay. All right, so what I want to do now is I kind of want to start to figure out what's the pattern here. Like when you raise a trig function to a power, right? So I'm going to give you a kind of a summary of the trig functions first, and then we'll come back and do this one. So the idea is if you have sine, cosine, secant, cosecant to an even power, or any tangent or cotangent. Think about what we just did here. We had sine squared earlier. That 2 is even. What was the period of sine squared when we did it? Pi. So to calculate the period, the formula for any of those is pi over b. Again, b, I didn't write it in, but b is the number in front of x. Let me just put that in. So if you look at that, what's left out? We've covered sine, cosine, secant, and cosecant to an even power. And we've covered tangent or cotangent all the time. The odds for sine, cosine, secant, and cosecant. So if it's sine, which is, this part is going to be important for the problem we're about to do. Because it's going to be a sine to an odd power. So, sine, cosine, secant, or cosecant to an odd power. What do you think the formula for the period? 2 pi over b. Does anyone have the top part? Okay, so it's 2 pi over b. And maybe you can come up with a different way to organize that, make it, I think that's relatively clear, but maybe you can shorten it up. I put absolute value because period is a measure of how long something is. Period can't be a negative number. If b was negative, that would cause a reflection. We're not interested in it. We're not looking at that at this point. All right. So now we don't have to play around trying to figure out what the period is. There's a formula that would summarize every trig function you could have in this class and how to find its period. It's either 2 pi over b or 1 pi over b. Okay, so let's look at ours. All right, what's the formula when you have sine to an odd power? 2 pi over b. 2 pi over what? 2. So the cubed controls part of what the period is going to look like, and the number in front of x also controls. So the period there is just pi. Now, technically, that's cosine to what power?
1.
It's really like cosine to the first. We don't normally write that. But technically, that's cosine to an odd power. What's the formula of just cosine? 2 pi. It's 2 pi over b, but this time b is 1. Least common multiple there?
2 pi.
2 pi. Now, the 3 has nothing to do with that period. That's a vertical stretch. Doesn't affect the period. All right, so let's graph that. So 3 sine cubed 2x. 3 sine cubed. Forgot the 2. 2x. Now put minus 2 cosine x. Minus 2 cosine x. Window should be 1 cycle, which would be 0 to 2 pi. And I think I'm already on that. Yep. Negative 5 to 5. That should show us everything. Because sine and cosine are continuous functions. They don't go to infinity. So negative 5 to 5 might even be a little bit overkill. I'm not sure. Yeah, I think it is. So we're looking for how many times it crosses the x-axis. And it should end exactly at the height that it started at. Okay. So that's what one cycle looks like. You just keep seeing that pattern repeated over and over. How many times does it cross the x-axis? 6. So you'd have to do second calc 0 6 times. I already have all the answers. Is there any question on how you would do it? 6 times. Okay, so the answers that you get are 0.5, 1.25, 1.57, 1.89, 2.65, 4.71. And every one of those answers should have what on the end of it?
Plus 2 pi.
Plus 2 pi n. So I'm just going to do it like this. Because all of those answers should have plus 2 pi n. And I think that's the one we do that has the most answers. Okay, so any questions on that one? So I just gave you guys the summary. All right, let's look at a couple inequalities, and that'll be it. So with an inequality, you're doing it the same way. The only difference is your answer is an interval. It's not going to be like x equals 0.4 plus 2 pi n. It's going to be an interval. So let's go like this. Let's say I gave you a graph, and it looks something like this. And I asked you where that particular graph was above 0? Well, it would be from here to here. So you'd have to find the roots, just like we did. And you'd have to describe that interval. Maybe it's 0 to pi. I'm just going to make that up. But what you want to put now is that interval is going to repeat every cycle. So then the next cycle down, you're going to get that same interval again one cycle later. And then you're going to get it again one cycle later. So you just have to tell me that the interval repeats over and over. Same idea. So answers are going to be intervals. Keep in mind vertical asymptotes. Okay. If there's a vertical asymptote in a problem, it's going to be pretty easy to find. It's not going to be a vertical asymptote that comes out to like a weird number. It'll be like 0, pi, 2 pi. Okay, it'll be an easy one to find. And that's important because when you're writing an interval, you can never equal a vertical asymptote. So what's the symbol we use on an interval if it can't equal? Parentheses. Yeah, use parentheses. Okay, so let's look at this one. I want to know where sine is less than cotangent. Okay. Let's do it like we've been doing it. Let's put everything on one side. So now what I'm looking for is where that graph is below the x-axis. Okay. What's the period length of sine? 2 pi. What's the period length of cotangent? Pi. Least common multiple? 2 pi. So when you write your interval, you're going to have an interval and you're going to put plus 2 pi n on each end of the interval, because you can take that interval and move the whole thing down one cycle. Okay. All right, now we're ready to type it in. So we've got sine minus. How do I type in cotangent? Yep, 1 over tangent. I'm just debating if I need a parenthesis around the 1 divided by tangent. It should do order of operations, should do the division first.
Yeah, sure.
Think it's going to be okay. Window. Oh, I must have pressed. Let's check our window. 0 to 2 pi looks good. So remember, we're looking for where the graph is under the x-axis. Okay, how many sections are under the x-axis in that cycle? 2. So we need to describe each one of them. First, we have to describe this one, and then that one. So keep in mind, that's just going to keep going down. Where does this first interval start?
0.
0. Include or not include?
Not included.
Not include. That's a vertical asymptote. I can tell because it's getting closer and closer. If I can't tell, go to your table, try to plug in 0, and it says error. If you go 0.0001, it's going to be way, way down. Okay, so that's an asymptote. So 0 up to. How do I get where this interval ends?
Find the 0.
Find the 0. Is it going to be a bracket or parenthesis? Parenthesis, because it's strictly less than. Okay. So let's do second calc 0. This could take a little while if you're not on the right spot. Okay. So left, right, enter. So we get 0.90. What symbol comes after this? Because I have another answer coming.
Yeah.
Yep. Or, now we have to figure out where this interval starts. Well, this was 0. This was 2 pi. where does it look like that vertical asymptote is?
Pi.
Pi. It's right in the middle of the screen. Told you I'd make the vertical asymptote easy to find. You can check it, and it is. Okay, it's at pi. Including or not including pi?
Not including.
Not including pi. Up to, where does this interval end?
There's 0.
It ends at 2 pi. And let's see, we cannot include that because whenever you set up a window, we usually include the left end, but not the right end. Because if you include both, like if you go from 0 to 360, you only want to include one. Don't include both.
Why is that too high?
Yeah, it's not too high.
Oh, no. It's not 2 pi. I said 2 pi. Why did I listen to you? Maybe I did. It ends right there. It does not end at 2
So
pi.
you have to find that.
I have to find it.
Okay, right.
Second calc,
That's about 5. That's 2 pi.
0.
That's that.
Okay, so move your cursor till you get all the way back into that other branch of the graph. Get close to the axis. Good enough. So yeah, it's definitely not 2 pi. Just go until that y value is positive. That's good enough. 5.38. Not including because it was less than. Now, that's the interval just in the first cycle. On each part of that interval, just put plus 2 pi n plus 2 pi n. What that means is you could add any multiple of 2 pi to those two numbers right there. Right? You could add 2 pi to them, and that would bring you to the next cycle down, okay? Where this is going to occur again.
So should you write it like after you close the parentheses?
Yeah, you can put it right there. That's fine. I mean, if you want it to be really technical about it, you should have. I mean, you could write it like this: 0 plus 2 pi n, comma 0.90 plus 2 pi n. That's the real technical way to write it, right? Pi plus 2 pi n, 5.38 plus 2 pi n. If you write it like I had up above, I understand what you're saying, but that's technically the right way.
So our test.
I would say accept either one. Questions on that? Okay. Let's take a look at this one.
Oh.
So this one, they said just graph it as is. Now, on the left, do you have a periodic function? Yes. How about on the right? No. Okay, so let's graph that. And keep in mind what I just asked you. Sine 2x, x squared minus 1. And I'm going to view this over one cycle. So the right doesn't have anything to do with periodic nature because it's not. It's a parabola. But what's the cycle of sine 2x?
2 pi. Nope. Pi.
Pi. So we're going to go 0 to pi. Window, that should be fine. Okay, so there's our graph of sine. And we're looking for where that is above or equal to a parabola that is about to be sketched, but the parabola actually goes back into the negative part, so I may have to look at that. So you know what, let's go like this. Let's go zoom center. So what I did, I just kind of zoomed out so you can see a bigger picture. So you're looking at lots of cycles. Now, we're looking for where the sine wave is above the parabola. Does that happen anywhere?
Yeah.
Yeah, it happens like inside the parabola. From here to here. Is it going to happen again in another cycle?
No.
No, because when you draw parabolas, they don't look like this. Parabolas don't repeat. If the parabola repeated, then the answer would repeat too. But this time the answer doesn't have plus 2 pi n because the parabola is only in one spot. Okay? So let's just call this intersection point A comma B, and let's call that C comma D. You could find them and you would know what they are. The answer here is between what and what? A and C. Including or not including?
Including.
Including. That's your answer. So find A, find C. And there you go. Okay. Any question on that? If the question was flipped around and said, where is the graph of sine below, it would be the opposite of that. Everything from negative infinity up to A, and everything from C to infinity. That's where the sine wave is under the parabola. Because the parabola goes up very, very, very quickly. Okay. I think we have 2 left. Let's maybe we'll let's get that one. Let's do this one. The last one we'll do is what's called a double inequality. So double inequality is when you have to graph 3 things like that. And basically all you're going to do is graph all 3 things on 3 separate lines, like y1, y2, y3, and then interpret the result. Now, with my calculators, it's going to help a lot because of the color. Okay? Black and white, you can still do it just fine. It's just the color makes it easier to see the answer. So, let's graph that. First part will be y1, second part y2, third part is going to be y3. Okay, so let's put that all in and see what we got. So we've got x, x, sine x. Now, look at that part for a second. X sine x. What does this number normally do as a transformation? It's a vertical stretch. So what that is, it's a variable vertical stretch, meaning the further away you go from the origin, the bigger vertical stretch you have. As you get closer to the origin, it's less of a vertical stretch and eventually becomes a shrink. Okay? So it's a variable vertical stretch. And let's put in x. So what we're going to be looking for, if we want to think about it like color-wise, negative x, I'll fix that. Negative x is going to be in blue. Let's put negative x. X sine x is red. And the last one is in black. So what we are looking for is where the graph in red is above blue or equal, but under the black. Okay. And let's just do zoom 7. So there's negative x. Might have to zoom. I think I'm gonna have to zoom out a little bit. I'm just gonna zoom out before it finishes. But maybe we'll let it finish. We do that too. Let's go zoom 3 out. All right. So there's our graph in blue. Here's x sine x, which is your variable vertical stretch, getting taller and taller as you move away from the origin. And here is our graph in black. So let's look at it. Where is the graph in red above the blue, but under the black? From the right, yeah, from 0 and up. Okay, so the answer here is from 0 to infinity. If you go to the left, the red graph is under the blue. No, that's not what they wanted. They wanted the red graph greater than the blue, or equal. That's why I use the brackets. Okay. Any question on that one? Okay, so last one this is where the color is really going to help. I'm just going to put in absolute values. Right, so let's go back here and go math, number, absolute value x, and math, number, absolute value x. Okay, and the colors are blue, red, black again. Blue, blue, blue. That's really confusing. I like the word blue and red. Blue, red, black. Blue. Ah, there we go. All right, so now, if we hit graph, there's an absolute value. It's a V shape with a negative, and a negative reflects it. The middle is just the variable vertical stretch again. Now the one on the right is going to be in black, and it's going to be a V shape that's not reflected. So if you compared these two pictures to each other, the one we did in this one, black and white, how, let me just move it up for a second. How would those compare if they were black and white?
They look exactly the same.
Yeah, it did look exactly the same. Okay. It looked that, and that's what would be a little confusing. So what I'm looking for is where the graph in red is above the blue, but under the black. Where does that happen? Yeah, from negative infinity to infinity. That's everywhere. It's always above the blue and under the black. Okay. It looks like an X shape again. This time it's really not. It's two V shapes, and the color shows that. So it looks kind of like the last one, but it is different. Okay. Any questions on that? It's probably, I think that's the first time we've ever seen a variable vertical stretch, constantly changing. Okay, so homework is on 401. Make sure when you copy it, a couple of those are just odds, 19 to 25, 33 to 37. Okay, the rest of it is all. Okay, so we'll go over that tomorrow, and then tomorrow will be our last day of new material for the week. Thursday. Plan right now is to do a review. Do some kind of review.